So my internet card works and it's really nice to have. It's kind of slow, but again, better than nothing. I tried to upload the last video, but it was too long or something. It took like an hour and a half to upload and then it said it didn't work. So we'll see how I do this one. In China, the currency, they're $1 coins, and then all the rest are, like below that there's a 50-cent coin and a 10-cent coin. And then there's like a penny one, but no one ever uses that one, which is nice. They round everything to tens since isn't any like sales tax either. There are also bills that go down to 10 cents, a 10-cent piece, but those are pretty uncommon as well, though not like rare or anything. So I always get $1 coins, which I don't lose because they're pretty big. They're bigger than quarters, I think, and the edges are smooth. But I always get dimes too, and I always lose one of them. Whenever I get, a multiple, the next time I look, there's always one missing, which is kind of strange. I found one of them yesterday in my backpack, or just this morning, but that's only one out of, many, which is kind of strange again. I went to the post office after work today. I walked like 30 minutes to get there too, and it was like 90 degrees. And they close at 4:30, and I got there at like 5:45. So that was kind of frustrating. Maybe I'll go during like the lunch break tomorrow or something, or I can find another one this weekend. What else? This morning it was very hot, and I guess this was the first hot day. It rained yesterday. Let's see, at work, okay, so this morning I poured 4 gels, and then I ran one of them, and then they're doing this thing, the company itself, it makes these drugs called biosimilars, and they're not like small chemicals, they're very large protein drugs, and they also do work with monoclonal antibodies. So some of the biosimilars that they're doing, they're cloning and inserting all these plasmid vectors with special inserts in them. So yesterday we started an inverse PCR thing to basically, if you have a plasmid with a special mutant section inside and you want just that, you can do inverse PCR. So it takes that and it makes its own kind of mini plasmid, and you remove all the other genetic code in it. So we finished that up today, and then every day we go through a ton of different plasmids, and just yesterday they got one of their clones' sequences back, and there are actually a lot of problems with the how they cloned it, not how they cloned it, how they sequenced it. The sequencing company made a bunch of mistakes, which we found out running through our gels and just looking at the letters. So those were resent back to the company today, so they can do a better job sequencing those plasmids. What's really cool is how so much of the theory is being used, like literally going through 5,000 or 6,000 base pairs and searching for like stop codons and other things was kind of interesting. I didn't learn, but I heard all the 20 amino acids in Chinese today. I remembered 19 of them without looking, which is also I'm very happy about that. What else did we do? They do this thing called ELISA, I think, and it's a 3-day process. So today is the 3rd day that they're doing it. They applied the drug to the microtiter plates, and then the second antibody, which is linked to an enzyme. And tomorrow I think they'll finish up doing the photospectrometering of it. Because it's a molecular biology lab, there's a lot of wait time. Like today we had to wait an hour while something incubated at something degrees, and there's a lot of wait time. So the people there, they'll bring their phones and stuff. And so today I brought the iPad to like read Wikipedia articles on. And it turns out all of them are huge Angry Birds fanatics. So they played Angry Birds for quite a long time on the thing. And yeah, they're very lax, and they watched a bunch of like American music videos all the time. And what else? They just like hang around in the lab, I guess, while they wait, because sometimes there's, again, not much to do. I don't know where I was going. One of them gave me an American textbook in a PDF file, and so I've been reading that. It's immunobiology, which is really interesting. I don't think it's too complex right now, but yeah, it's giving me a lot of background information about the stuff they're doing, which is really cool. Yeah. A lot of so they're making these biosimilars and these antibodies, and one of the things that they're testing right now is what the FC, so antibodies are all in like a Y shape. There's the two parts with the the antigen attachment sites, and then there's the base pair, or the base of the antibody, and that's called the FC section, the fragment crystallizable section. And so they've been isolating a lot of those and creating inserts of DNA that encode for special FC fragments, and they're inserting those into a bunch of E. coli bacteria via the plasmids that they're creating. And so, yeah, we impregnated, I think that's the right word, an agar dish today with some of the bacteria that they're testing. So we get to isolate the colonies that have successfully been transformed, is what you call it when you can accept DNA from an outside source and integrate it into your own genome. So we'll isolate successfully transformed E. coli colonies tomorrow, and then from the petri dish, and then I think they're going to be sent off to be sequenced as well, just to verify that they are the clones that we want. What else? I don't know. I think that's it.